Deciphering Space-Time, Mass Energy Field and Cosmic Physical Phenomena. Today, we continue to share with you 200 Working Days in a Lifetime, a gift of intelligence to humanity. Written in 2013, this book not only foresaw all the problems we face today, but, more crucially, proposed solutions to them. Next, we will share our understanding and insights of this book. Picking up where we left off last time, today we will jointly decipher space-time, the mass energy field, and cosmic physical phenomena. Have you ever wondered what lies at the heart of the dispute between the general theory of relativity and quantum mechanics? I once came across a view that the fundamental issue is that both theories regard space-time as an independent variable. If that is the case, how can we resolve the contradictions between them? As I understand it, the general theory of relativity holds that space is smooth and continuous, while quantum mechanics argues it is discrete and fragmented. Isn't this a stark contradiction? In fact, the problem can be easily solved simply by acknowledging that mass and energy are opposed in their directional selection. We don't even need the concept of a singularity. Consider the uncertainty principle. If we chase light to measure the speed of light, we will never succeed. This shows that we have to sacrifice light's spatial motion to measure its speed. The same applies to microparticles. Observing them with a gamma-ray microscope disrupts their mass constraints. To measure an orbit, we have to sacrifice momentum. To measure momentum, we have to sacrifice the orbit. Otherwise, the conservation of mass and energy will be violated. So that's how it is. Does this mean that the uncertainty in the microcosm is caused by gamma rays altering the mass energy field? Then is there no uncertainty in the macrocosm? There is. After all, there are no absolutely definite coordinates, only relatively definite ones. Rest is relative, and motion is eternal. We usually take approximate values as definite ones. Logically speaking, the uncertainty principle is the reason for the universe's absolute inviolability. If intelligent beings could measure the universe with absolute precision, the cosmic trajectory of motion might be altered, and this is certainly not permitted. By the way, do you think the speed of light is absolutely insurmountable? I've always believed it is, but is that really the case? The speed of light is indeed unbeatable in the temporal dimension, but not necessarily in the spatial dimension. Unlike macroscopic objects, it is normal for quantum particles to move faster than light in space, which explains the superluminal phenomenon in quantum entanglement. Moreover, the motion of the early universe and many current galaxies in space is often superluminal. Without superluminal motion in space, we would never be able to see light from the past. This has completely overturned my previous understanding. What about the motion of matter then? We usually think that the Earth orbiting the Sun and electrons orbiting atomic nuclei are forms of active motion, but is that incorrect? Actually, it is. For matter that abides by the principle of minimum energy consumption, the universe only has two coordinates, space and time. The spatial coordinate axis of matter only has an inward and outward direction, with no such concept as positional localization as we define it. The so-called orbital motions of the Earth and electrons are actually relative rest. Only a sufficient amount of energy to influence the mass energy field can break this state of rest. Furthermore, the energy field changes continuously, but orbital transition requires the accumulation of enough energy. Not all changes in the energy field will cause matter to change its orbit. So that's it, microcosmic and macroscopic changes are unified in this regard. How then are black holes formed? When mass reaches a sufficient magnitude, the value of the surrounding mass energy field drops abruptly. Light and electromagnetic waves passing by will curve inward and be unable to escape, thus forming a black hole. As a black hole continues to devour matter, its space shrinks, temperature and pressure rise, and the efficiency of mass-to-energy conversion increases. Eventually, it reaches the critical point of sum E equals sum mc and explodes once again. However, I find Hawking radiation unreasonable. Its logical starting point is the conservation of energy, which may not apply in the extreme environment of a black hole, and the notion of virtual particle-antiparticle pairs sounds more like theology. That makes sense. What about redshift and blueshift? When light passes a massive star, the intense energy in the star's mass energy field causes the light to curve outward. increasing its travel distance, wavelength, and decreasing its frequency. This is redshift. When two celestial bodies move toward each other, the travel distance of light shortens, and the light curves inward, resulting in blue shift or violet shift.